Hey, y'all, let's cover section 4.2. So this is all going to be writing linear functions based on word problems. Building linear models from verbal description, same thing. Elin is a college student who plans to spend a summer in Seattle. Elin has saved $3,500 for their trip and anticipates spending $400 each week on rent, food, and activities. How can we write a linear model to represent the situation? So let's start with that first. Whenever I have a word problem, I've told you that I use b plus or minus mx instead of mx plus b, because it's easy to start off with what the initial value is and then figure out if you're adding or subtracting from it from a constant rate of change. So our formula or our function is going to be what? How much is Elin starting off with? They're starting off with $3,500. So that is the initial value. From that, they're taking a trip and spending, since they're spending, they're subtracting from that $3,500, $400 each week. So what you need to understand is this the amount of money left over, amount or available or left over after each week. And then X is the number of weeks. The next question is, what would be the x-intercept and what can Elin learn from it? Well, we've done one similar to this before, and what they're asking us to do is set f of x is equal to 0. So if f of x equals 0, which y equals 0, then that would mean that Elin would have 0 money left over, and it would tell us how many weeks Elin could stay in Seattle. So if we solve for that, 3,500 minus 400x, I'm going to add 400x to both sides. And I get 400x is equal to 3,500. Divide both sides by 400. And x is equal to what? 8.75. So that means that Elin can stay in Seattle for, well, could I round this to 9? Could Elin stay in Seattle for 9 weeks? No, does not have enough money to stay in Seattle for 9 weeks. You could say 8 weeks as an answer. That would be accurate. Or you can just say 8.75 and make sure you represent the correct units. When answering a word problem, you should be answering in sentence format with correct rounding and correct units. That's what I'll be looking for. A town's population has been growing linearly. In 2004, the population was 6,200. Oh, this is ordered pairs. 2004, remember time is always your X value. The population was 6,200. And in 2009, the population, oh, should be a comma, sorry y'all. 2009, population is 8,100. Assume this trend continues. Predict the population in 2013 and identify the year. Okay, you can't do any of this until you've created a linear function. To create a linear function, we need to know what the slope, the constant rate of change, or the slope is. So m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. All right, so x1, y1, x2, y2. 8,100 minus 6,200 divided by 2009 minus 2004. I know the denominator is 5. Let's find the numerator. 8,100 minus 6,200 is 1,900. Divided by 5 is 380. Okay. So we're going to create our linear function. F of x is equal to, well, what's the initial value? What's the earliest population we know? And that is 6,200. So 6,200 Are we adding to the population or subtracting? Well, 8,100 is going up, so we're adding to the population. We're adding 380 new people per year. So X is the number of years after the initial value, which was in 2004. And then this is the population based on years after 2004. Okay. Predict the population in 2013. Well, we're not going to plug in 2013 here. We're going to have to find out what is the difference between 2004 and 2013. The other direction. Come on, Sandra. All right. So that's 9. So it's 9 years after 2004 is 2013. So F of 9 is 6,200 plus 380 times 9. So 380 times 9 is 3,420 plus 6,200 is 9,620. So the population in 2013 was 9,620. And that answers the first question. The second question is identify the year in which the population will reach 15,000. If you do not know what each of these values mean, you're not going to know where to replace things with. So because f of x is the population, I'm going to take where the f of x is and substitute it for the value that they're wanting me to find. So I'm substituting 15,000 for f of x and solving for x. Subtracting 6,200 from both sides. 15,000 minus 6,200 is 8,800. And then divide both sides by 380. And that is 23.2. Okay, that is not our answer. Our answer is what? The population will reach 15,000 and we need the year. To find the year, we have to take the original 2004 and add 23.2. So that's 2027.2. So it happens in 2027. And that is the answer for B. Expect something like that on your exam. Try it as a chance for you to do this yourself. So I'm going to give you a chance to do this one. It's the same exact type. We'll do it in class. Using a diagram to model distance walked, I'm mixing them. Anna and Emmanuel start at the same intersection. I have to draw this. Anna walks east at 4 miles per hour while Emmanuel walks south at 3 miles per hour. They are communicating with a two-way radio that has a range of 2 miles. Let me draw this. So we'll say that north is this way. So if they're starting at the same intersection and Anna's walking east at 4 miles per hour, so 4x. And Emmanuel's walking south. I know this is not drawn to scale, 3x. They're communicating with a two-way radio that has a range of 2 miles. So from here to here cannot go past 2 miles. How long after they start walking will they fall out of radio contact? Well, this is just a right triangle. So we can use Pythagorean theorem, which is a squared plus b squared is equal to c squared. All right. So a, we're calling 4x. B is 3x. And the reason I know that 2 is my hypotenuse is because it's directly across from the right angle. The hypotenuse is always directly across from the right angle. 4 squared is 16, x squared. 3 is 9x squared, and 2 squared is 4. We're just going to solve for x. This is 25x squared is equal to 4. Divide both sides by 25. So we have x squared is equal to 4 over 25. You can take the square root of both sides. Remember, when we're having an x squared equals something, you have to put plus or minus on the right. So x is equal to plus or minus 2/5. Square root of 4 is 2, square root of 25 is 5. Here's the gig. We're not going to use the negative. We're not going backwards in time. This is not, what is it? I was going to say the one with Michael J. Fox. I can't remember. I'm just gone. But it's 2/5. 2/5 of what? It's 2/5 of an hour. And we don't talk like that. So instead, we're going to take 2/5 of minutes. We're going to take 60 minutes instead, so that we can know what that is. So 2/5 times 60 is 24 minutes. So it will take 24 minutes to lose radio contact. And that is our answer. Modeling a set of data with linear functions. Real world situations include 2 or more linear functions. So up to now, we've only been dealing with 1 linear function. Now we're going to talk about 2. Remember, when solving a system of linear equations, we are looking for points that the 2 lines have in common. Typically, there are 3 types of answers. Only one solution. That means they cross each other only once, and the place that they cross each other is that solution. Infinitely many solutions means that they're the exact same lines. So say that we have x plus y is equal to 3 and 2x plus 2y is equal to 6. They're the exact same lines, okay? The next one is no solutions at all, and these are parallel lines. They will never touch, okay? This is not perpendicular. They do cross each other, but perpendicular means they're going to create a right angle. This is not the case per se, all right? So building a system of linear models to choose a truck rental company. This is a great real life example. The only thing I'm going to change here to protect the innocent is to make it easier for us to see. I hate using these names. I should change this at some point. So let's use U-Haul and Budget, because those are rental companies I know. And then we'll use U-Haul is what we're going to be looking for. All right, Jamal is choosing between 2 truck rental companies. The first is U-Haul, and it charges an upfront fee of $20.59 a mile. The second's Budget, and they charge an upfront fee of $16.63 per mile. When will U-Haul be the better choice for Jamal? Okay, so I label these. And let's just create them. So if we have U of M, because we're going to use M as miles, U-Haul has an upfront fee of $20 plus 59 cents, 0.59 per mile. M is miles, and U of M is price per miles for U-Haul. So U-Haul. Budget will use B of M, and that's going to be the price per miles for Budget is equal to, they have a $16 upfront fee plus 63 cents per mile, and M is miles. All right. If we're just looking at this, who is the better choice just right off the bat that you see? One starts at 20 bucks, one starts at 16. right off the bat, I'm wanting to go with budget because they've got a cheaper upfront cost by $4. Okay. But there's going to be a point where these two have the exact same price. After that, because U-Haul is going up at a slower rate than budget, U-Haul will then be our better choice to rent. All right. But we need to know at what is that point that they are equal in pricing. And to find that out, we just set them equal to each other. I don't mean the whole thing. I mean just the linear function part is equal to this part as well. 16 plus 63m. And we're going to solve for m to find out where they're equal. I'm going to subtract 16 from both sides and subtract 59.59m from both sides. 20 minus 16 is 4. It's gone. Gone. And then this is 0.04m. Dividing both sides by 0.04. I get m is equal to 100. So at 100 miles, they're the exact same price. If I'm wanting to move from my house here on the upper side, north side of Jamestown, and I want to move to the south side of Jamestown, I'm going to be going with budget because they're going to be my cheaper route. It's not going to reach 100 miles. I'm going with budget. If, however, I'm moving from Jamestown to Rochester, that's more than 100 miles, and therefore U-Haul is going to be my better bet. The question is, when will U-Haul be the better choice for Jamal? U-Haul is the better choice after 100 miles. Even if it's 100.01, it's still the better choice. Okay. Let me know what questions you have regarding that. I give you one more. I think this is a U try. So we'll do this one in class. Let me know if you have any questions on anything that we've done today. Kelly?